I love the fact that you are beginning to see this whole picture. Now in this video, I want to show you what do I mean by the 5 types of functions. What are they? Okay, I'm going to show you in the syllabus. Don't worry. Hold up. I'm going to go and show you what I'm saying. I'm just going to show you in here what are the 5 types of functions and what are the 4 rules. And then I'm going to show you what is for AS and what is for A2. Then I go and show you where it is in your syllabus, okay, on the content overview section. And if you go even below that, like when you go to the structure, okay, when you start to see the things. So the 5 types of functions, this L represents, let's go and put it, since now you've kind of seen the thing. I need a page where there is more space. So the 5 types of functions, remember, we got to know the types of functions, the 5 types of functions, because you need to know how you differentiate each one of those 5. You need to know how you differentiate L functions, I, P, E, and T. So let's put it. So this is going to be lipid. And I want you to know that this lipid is also, it so happens to also be something you're going to use in integration when you do integration by parts. So it's a 2-in-1 thing. So I'm making you know the types of functions, but I'm actually making you know in a special order, which is an order you're going to use again in integration. So just remember that, and you're going to see. So what are the types of functions lipid? What is L? L is logarithmic functions. So L is logarithmic functions. And what is the logarithmic function that you are going to need to know for AS? Remember, we did not say this is the whole of differentiation. No, but we said this is the whole thing that we have to know for Cambridge AS and A2 mathematics. Okay, when there's no need for us learning calculus stuff. Okay, there's no need for us trying to learn the calculus differentiation, the one that engineering students do in engineering mathematics. We can. I know you're very capable. You're mentally capable, and I can take you through all that, but it's not important. Why would I take you through that right now when we're doing Cambridge AS and A2? So we're focusing on this, okay? But if there is ever a need, then we can go through that, okay? When you get to engineering, if you want. Now that is if you're going to do engineering. Let's do the second type of function. This is I. This is differentiation for us. This is where it ends. The I is inverse trig functions. I'm going to give you examples, okay? This is inverse trig functions. Then what else do you have? P. What is P? We go down and we put P. P is going to be polynomial functions, okay? P represents polynomial functions. Then what is E? Let's bring it down. E is going to represent exponential functions. So let's put E. E is exponential functions. Then what is T? T is trig function. So let's put T. So let's go and put for T. T is now representing trig functions. So T is trig functions themselves. So we have inverse trig, yes, and we have trig, yes. So what are the 5 types of functions? We have logarithmic functions, we have inverse trig functions, we have polynomial functions, we have exponential functions, and we have trig functions themselves. So let's put, if I want to know, then let's put, what are the logarithmic functions? The logarithmic function you only have to know is this one. Y is equal to ln x, okay? You have to know the logarithmic function which says ln x, but for us to make it as a function, either we can say y is equal to ln x, or we can say f of x is equal to ln x. This is the logarithmic function, and we should know how to differentiate it. We should know what its derivative brings. Okay, then we're going to start to use it in the chain rule where we combine it with other things, in product rule where we multiply it with something, so we can start to then join it with other things. But we need to know how to differentiate ln x. This logarithmic, you have to know. It's a requirement. Then you need to know how to differentiate inverse trig. Which ones? For differentiation, you only need to know how to differentiate tan inverse of x. These are inverse trig functions. The inverse trig functions, we have 3 that you are going to meet in your AS and A2. Y is sine inverse of x. Then we have y is cos inverse of x. These are the inverse trig functions, okay? Because trig functions themselves, you have to know 6 or trig or more. For inverse trig, there are 3, but you only have to know this one. That's the one you got to know. You need to know how you differentiate tan inverse of x. Y is equal to tan inverse of x. We need to know how we differentiate it. And I want you to see something which is going to be very important for us as we go through the rules as well, especially when you're learning them, is that when we say you have a logarithmic function, and when we say we have the logarithmic function, it is y equal to ln x, nothing else. Ln x, x itself, that's the logarithmic function. When we are going to start introducing other things, it is going to become something else. The logarithmic function is y equal to ln x. Please remember this. For trig functions, there are 6, and you gotta know in their order because it helps. And this order, if you're forgetting it, you can go and confirm it in MF19, I guess. So what are the trig functions? What are the 6? We have sine x, we have cos x, we have tan x, we have sec x, then we have cot. Okay, we have sec x, right, after tan, then we have cot x, and then we have cosec x. Okay, because when we start to do differentiation, you're going to see that these two are related, these two are related, and these two are related. Okay, so it's so it's sine, cos, then tan, then sec, then cot, then cosec. These are 6 trig functions, and guess what? You gotta know their derivatives, all 6 of them. Okay, and for some you're just going to get it in the MF19, but I'm going to show you because it is good and it's easy. So we have, you can say y equal to cos x, you can say y equal to tan x, you have y equal to sec, you have y equal to cot, you have y equal to cosec. These are the things. So here we have them. These are your trig functions, 6 of them: sine, cos, tan, sec, cot, and cosec. Then what do you have? Exponential functions. What is an exponential function now? It is a function where x is the power. So when x is now the power, we say we have an exponential. So y is equal to e to the x. This is an exponential. Y is equal to 7 to the power of x. This is an exponential. But guess what? We won't do this one for 7 to the x. The only one you are expected to know is where e is the base. So y is e to the x. Okay? And then what are polynomial functions? These are just the general ones where you have x's and powers. So 5x squared plus 3x minus 9, y equal to this, or you have even y equal to x, or you can have y equal to x cubed, whatever. These are the polynomial. Can you see them? Just writing something where you have x's and powers. This is a polynomial, including a digit. If we say x cubed plus 9, this 9 is part of the polynomial. It's a polynomial. We work with that. So these are your functions. Can you see them? Are you sure? Can you see them nicely? Good. Logarithmic, inverse trig, polynomial, exponential, and trig. These are the 6 types of functions, and you gotta know how to differentiate each one of them. That's not the lesson today, because we're going to partition it to show you this is for AS and this is for A2, and you can go to the appropriate revision series if you want to do the differentiation of a certain part. If that's what you want to learn, if you want to learn how to differentiate trig functions, then you just have to go to the P3 revision series, and then you can see the videos I put on it. But here, types of functions, you gotta know how to differentiate all of them. Okay, lipid. Well, I need to know how to differentiate all of them. Then what are the 4 rules? So now let me say something. When you are differentiating polynomial functions, okay, this is the part that is going to come in AS. Only the polynomial function. The rest is going to be A2. It's going to be P3. So in P1, we are going to work with differentiating polynomials. So polynomial functions, you are going to learn how to differentiate these ones in AS. Then logarithmic, inverse trig, exponential, trig themselves. These are the 4 you are going to learn how to do it for P3 and in P3. So when you're going through P3 and preparing for the P3 paper, that is when you do these are the 4. Now, what else do I want to tell you? We want to talk about the rules. For the rules, the first rule, you have 4 rules. The first rule is for polynomial functions. It is to tell you how you differentiate polynomial functions. That is what the first rule is. It is only for polynomial functions. Then the other 3 rules are now for combinations. So polynomial functions, what do I have? What are the 4 rules? Because we said you gotta know the 4 rules, right? The 4 rules are just, I'm not gonna go through all of them right now and teach you, because you go to the appropriate thing and you're going to see. But I'm just going to give you the summary so you can see. There's going to be the power rule, and then we have the product rule. They are so simple, these rules. These rules are just so simple. Okay, the power rule, then you have the product rule, then you have the quotient rule, okay? Quotient rule, and then finally you have the chain rule as the 4th. So here are the 4 rules. Now, here the power rule is just to say when you have y being equal to ax to the n, which is a polynomial, right? It's a polynomial. How do you differentiate a polynomial? Dy dx. It's just how you differentiate a polynomial, right? We're going to do more on this, but it'll be just saying that dy dx is you drop the power. So the power is n. You drop it and it's going to multiply a, which is the number which will be in front of x. So you now have it as an. Then you reduce the power by 1. It becomes x now to the n minus 1. So the power goes down by 1. This is going to be only for polynomials. This is how you differentiate a polynomial, okay? So then the product rule, quotient rule, chain rule, these are now for combinations of functions. These will work for all these other guys. All these other guys. But now, these 2 you will learn here. These 2 you will learn them for P3 and when you are doing P3, right? That is when these 2 are done. The chain rule is introduced at AS. So introduced, I want you to understand this, introduced for P1. That means when you are preparing for P1, point number 1 is you are only going to know, so only this for P1. When you're preparing for P1, yes, you only have to know how to differentiate polynomials. And how? Using the power rule. Then you are going to need to know how you differentiate them when they are joined together, which is something, this is very important, because somebody might be saying to me, when you taught me the types of functions, why didn't you teach me composite functions? It's not a type of a function, sir. Composite functions are functions that are made when you combine other functions. When you combine functions, you can create a composite function by combining functions, okay? It is created. So you are going to then learn, so what am I doing for AS? What is AS? For AS, you just need to know how to differentiate polynomials. Logarithmic, inverse trig, exponential, and trig themselves, all these other types of functions are in P3. So for P3, that is when you are going to do these other 4 types of functions. And when you do them, you are then going to see how you combine to get to have function that has 2 things multiplying, and how you differentiate that using the product rule. So you're then going to come learn about the product rule, which is how you now combine these functions and differentiate it. So you'll be now differentiating combinations. When 2 functions are multiplying and you want to get the derivative, we're going to use the product rule. Then the quotient rule, okay? The chain rule is when you put one function inside another, and you are going to learn it in P1. But then you are also going to use it in P3. But for P1, what will you be joining? Only polynomials. For P1, chain rule is for composite functions, and we are going to learn that. But what is a composite function? It is when you put a function inside another. For example, you can say x squared plus 5x plus 9. You raise it to the power of 3. If I ask you, what type of a function is this? Is this a polynomial? No, it is not. Because we saw the polynomials. What are the polynomials? It is this. There is no power outside. So now if I have a power outside, it is not a polynomial. So what is it? It's a composite function. You have something inside and something outside. And for this, you are going to use the chain rule. And that's okay. Okay, so now, I got to wind down because the video has been long. Let me just say, what is AS differentiation? This is your differentiation, right? For AS, you have to know 2 rules. Out of how many? 4. And what is this? Number 1, power rule and chain rule. Okay? Chain rule is introduced here. Now, then what? Then you have to know the whole of application of differentiation. Okay? And why is it that you have to know 2 rules? It's because you only do one function. And what is it? Polynomials. So polynomials, for us to differentiate them, we use the power rule. We only do one function. And for that one function, we need to know how to differentiate it, and that's the power rule. Then we need to know how we differentiate it when it is combined by putting one power rule inside another, one polynomial inside another. That makes a composite function like this one, which we differentiate by the chain rule. Now, sometimes they'll give you to say, why is the square root of 3x plus 5 is the same as this? Because for us to differentiate, we never can differentiate anything with roots. We change it, and a square root, you're going to see it changes to 3x plus 5 all to the power of half. We change it to a power. And once it looks like this, we can see that this is another chain rule type of problem. So what are we saying here? For AS, we are going to need to know how to differentiate polynomials only. Then we will see the chain rule where we differentiate them when they are combined. One is put inside another. Then we do the whole of application. You learn how to use the derivative to find the equation of a tangent. So after finding this derivative of a polynomial, we're going to use it to find the equation of a tangent. We're going to use it to find the equation of a normal line. We're going to use it to find the stationary points. You're going to use it to do the whole of that application, which I wrote down for you. The whole picture. Where is it? This whole of application is going to be in AS. You are going to first learn about it in AS. Then for P3, now what should I know? A2 differentiation. That is for P3, okay? Okay, for P3. What are we going to know now? For P3, we gotta know how to differentiate the other 4 types of functions. We need to know how to differentiate the other 4 types of functions in Lipid, which is L, I, E, and T. Okay? E and T. Okay? P is gone. We already now know. So here we are now learning how we differentiate these other. And we are going to just use a table, which is called the common derivatives table. Then we are going to see how we do the other. We say 3 rules. I'm going to say 3 rules because if I say 2, it won't be accurate. The other 3 rules, which is going to be the product rule and the quotient rule and so it's quotient rule and the chain rule again, because we are now going to combine these guys to form chain, and we'll be now seeing what does the chain rule look like when it is a logarithmic function. We know how to see it on a polynomial, but what about for a logarithmic? For a polynomial, we saw it was like 3x plus 5 all to the 7, y being equal to something like this, which we cannot expand. We can't expand to make 1. So what are we going to do? Well, we are just going to use the chain rule here. Let's say it was again 3x squared plus whatever. We cannot expand this. It's a very high power. We're not going to use that. So what we're going to do is just to use the chain rule. So this is what we're going to do. For A2, A2 is this. Then you are going to learn about parametric and implicit. Okay, you are going to learn about parametric and implicit functions and how we differentiate them. And you are done. You are also going to then apply. Okay, you're going to do application, but you remember, you'll be already knowing how to do the whole thing. Okay, because you learn application in AS, but now you'll be just using different functions. You'll be now just applying, but the methodology, you'll be knowing it because you'd have done it in AS. Because in AS, you are going to use the derivative of polynomials for every single type of application. Are we together? And the A2 now is what? 4 types of functions. What? The 3 rules. What? Parametric and implicit. Then more on application. We use it to apply again. And here it is from the thing. Then I close this video off. Here it is what I'm saying. Here it is from your syllabus. It's saying for differentiation, what should you know? This is like, these are the second derivative and the third derivative. We are fine with that, don't worry. But here you should know derivative for x to the n. This is just the power rule. And what else? The chain rule. For what? For only for polynomials. Here is a polynomial like this. Then here we have another polynomial like this one. But this one, we saw that this is the one where we will use the chain rule. We can't say it's a polynomial. This is a composite function because there is one inside another. Then we use the whole thing which is below here is now just application. We can say they are saying apply this whole other. So it's power rule and chain rule. But remember, it is only for polynomials. The other types of functions, no, we won't. So only polynomials. Then what are we going to do here? The rest is application. The rest is application, and it is done here at AS. Application, yes, we've used to find what? Gradient, to find tangent equation, to find equation of normal, to find weight is increasing and decreasing, to find rate of change, to find stationary points and their nature. And then of course we can sketch a graph if we know all that. Okay, and here the rate of change and the connected rate of change. Okay, these are applications. How we find the gradient, how we find the equation of a tangent, how we find the equation of a normal, how we find the interval it's increasing or decreasing, the rate of change and whatever. The whole application is AS. This is pure mathematics 1. This is AS. Then we continue to the part for A2 is right here. Let's go and we see how small it is. Where is it? 3.8. No, 3.4, I guess. Here it is. What do we have? Look at this. The 4 other types of functions, which is exponential, here logarithmic, here trig, and here inverse trig. We said for inverse trig, you only have to know tan inverse of x. So this is now the 4 other types of functions. You have to know how to differentiate them. Remember, you have 5. You have done polynomials for AS and you applied. You did application of differentiation. AS is only the polynomials and we use them in application for differentiation to find equation of a normal, equation of a tangent, blah, 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 blah. And we are done. We do application mostly. That's what AS is for. Applying. The derivative is going to be easy to find because it's just a polynomial, okay? Or it will be a composite function where you put a polynomial inside another and we use the chain rule. But now when we come here, you now need to know how do you actually differentiate the other 4, the exponential functions, the log, the trig, the inverse trig. Then you do the 3 other rules. Okay, you do the other 2 rules plus you do the chain rule again. You are going to do the chain rule. Why? Here is why I know. Because I've seen it and also because here is the word composites. Composites is when we join them so that we can use the chain rule. And what else? These are the 2 rules, product rule and quotient rule. Then finally, what do we do? Parametric and implicit. And we are done.